Hello algebra students, this is Mr. Von Ah, and we have another video for you. We have learned how to solve quadratic equations. We did it, 4 different ways. And now we're going to learn how to graph them. This is kind of the introductory video for graphing quadratic equations, all right? So our objective today is that students will be able to graph quadratic functions of type f of x equals ax squared. All right, so this is the most basic type of quadratic function. You notice there is no b or c term, it's just the a term. All right, so what I have here is I have a little coordinate grid set up for us that we're going to be using. And I have 4 different really quadratic functions we're going to graph, just so that you can see what happens to the graph when my a term changes. All right, here a is 1, here a is 2, here a is 1/2. And also what happens when this a becomes negative. Okay, so that will help you, I think, a lot in just knowing what these graphs are going to look like. All right, so let's go ahead and start with the most basic quadratic function, and that's f of x equals x squared. All right, so what we're going to do here is each one of these is going to form a parabola. All right, a parabola is kind of like a U shape, right? And right in the middle. So the thing about a parabola is it has a line of symmetry. Okay, if you picture a U, right, a line of symmetry goes right down the middle. All right, and we're gonna identify those different parts for right now, but just suffice it to be said that that vertex or that line of symmetry is very important because it's going to tell us where we're going to choose our x values, all right? So basically what I did is I just set up a table. I have x values and I have f of x values. And you can just think of f of x as the same as y, all right? X and y. Okay, so what I'm going to do is I know that my vertex is going to be at 0, and we're going to learn how to identify the vertex later. Okay? But right now, I know that the vertex is 0. So what I'm going to do is I'm going to put a 0 right there for my x value. All right? So what I need to do is I need to find 3 values that are less than 0 and 3 values that are greater than 0. It could be 2 values, at least 2, but 3 is even better if we can. All right? So I'm going to think of 3 values that are greater than 0. All right? Well, I'm going to get 1, 2, and 3. Okay, now I'm going to think of 3 values that are less than 0. And by the way, choose easy numbers, right? I'm going to choose -1, -2, and -3. All right, so now for each one of these x values, I'm going to determine what my f of x values are. Okay, so when x is equal to -3, okay, I get -3 squared, which is, well, -3 times -3 is 9, right? So at f of x equals at x equals -3, f of x is going to be 9. All right, when x is -2, all right, I just substitute that -2 here. -2 squared is 4. Okay, so at x equals -2, f of x equals 4. At x equals -1, what does f of x equal? Well, f of x equals -1 squared, which is 1. And at x equals 0, f of x is going to be, well, 0 squared, that's an easy one, right? F of x is also going to be 0. Okay, now what happens when we get into the positive side of our function, of our x values, I should say? Well, at x equals 1, 1 squared, 1 times 1 is 1. And when x equals 2, 2 squared is 4. And at x equals 3, 3 squared is 9, so f of x equals 9. Now I want you to notice something. Do you see something that's happening with my f of x values? if you need to pause the video just to kind of study it and see what's happening with my f of x values. Well, as you can see, it goes 9, 4, 1, and 1, 4, 9. There's some symmetry going on here, which we'll be able to see as we graph this. All right, so let's go ahead and graph this. So at negative 3, 9. All right, so I'm going to start at my origin, and I'm going to go, my x value is negative 3. So I'm going to go over, right, this is my x-axis. This is my f of x axis. Okay, so I'm going to start at my origin. My x is negative 3. 1, 2, 3, right, to the left. My f of x is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my first point. All right, how about at x equals negative 2? 1, 2. F of x equals 4. 1, 2, 3, 4. All right, and now at x equals negative 1, I simply go over 1. My f of x equals positive 1. So I go right there. All right. And at x equals 0, of course, f of x equals 0. All right, so I have half of my parabola here. Now watch what happens as I go to the positive side of my x values. At x equals 1, which is right here, f of x equals 1. See how that's the same level as the negative side? At x equals 2. 1, 2. F of x equals 4. 1, 2, 3, 4. See how that's the same level as that? And at x equals 3. 1, 2, 3. F of x equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same level. Right? And if we draw this, if we sketch this, it's going to give us something that looks something about like that. I'm a little off, but that's okay. Okay, so you can see that I have, that's called a parabola. Okay, and you'll notice that my parabola has a line of symmetry that goes right down the middle. Kind of like your body. Your body has a line of symmetry right down the middle, approximately, right? Your left side is approximately a mirror image of your right side. Well, the parabola, it's the exact mirror image. All right? So we call that the line of symmetry. And I don't know how to spell symmetry, so I'll just give it a bit of shot there. Line of symmetry, or LOS. Okay, also one thing you'll notice, see this minimum value here? Where the parabola changes from one direction to the other direction? We call this, it's a very important place on our parabola, we call that our vertex. Our vertex. Okay, that's going to either be my minimum value or my maximum value depending on the orientation of my parabola. All right, so there's my graph of the function f of x equals x squared. All right, now what do you think is going to happen to our graph when a increases from 1 to 2? Well, let's find out. Okay, so we're going to choose our x values. Again, this time we're going to use red. I'm going to go 0, negative 1, negative 2, negative 3, 1, 2, 3. So you can kind of see why I needed, see there's my 0, x equals 0. You can see why I needed 3 values less than x and 3 values greater than x. Right? Because the line of symmetry is going to pass right through my vertex, which is at x equals 0. All right, so at x equals negative 3, okay, now be careful here. You got to do your order of operations. Exponents come before multiplication, so you don't go 2 times negative 3 first. You got to go negative 3 squared, which is 9. 9 times 2 is 18. All right, negative 2 at x equals negative 2. Negative 2 squared is 4. 4 times 2 is 8. Negative 1 squared is 1. 1 times 2 is 2. 0 squared is 0. 0 times 2 is 0. And here's a little trick that will help you save time on these. Once you have these 4, you can fill in the next 3 without even doing any math. Did you notice how this was 9410 and then 149? 18820. What do you think this number is going to be? It's going to be the same as that number. 2, 8, 18. All right? Okay, so let's see if we can graph this. Negative 3, 18. All right, well here's 1, 2, there's negative 3. But the problem is we don't have enough, our coordinate grid is not big enough. So we're not going to be able to really graph this with what we have. Remember what I said, it's nice to have 7 points, but 5 will do the trick. All right, so we're not going to be able to graph that. So let's graph this one, negative 2, 8. So we come over 1, 2, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. Whoa, wrong color. 1, 2, 3, 4, 5, 6, 7. Right there, is that correct? 1, 2, 3, 4, 5, 6, 7. Yes. All right, negative 1, 2. Negative 1, up 2. 0, 0. 1, 2. And 2, 8. Okay, so let's go ahead and graph this. Let me make that a little thicker. All right, so there is f of x equals 2x squared. What happened to my graph? Well, it got thinner, didn't it? All right, so here's the thing. As a increases, right, the thinner your parabola is going to get. All right, so that means the smaller a gets, the wider it's going to get. So if this is at a equals 1/2, we should expect that the graph will be wider. Let's try and find out. We're going to do this one in green. All right, so again, we're going to do our same points here. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay, at negative 3 squared is 9. And 9, half of 9 is what, 4.5? Okay, and at x equals negative 2 squared is 4. Half of 4 is 2. Negative 1 squared is 1. Half of 1, well, is a half. We're using decimals here, aren't we? And that's going to be 0. And again, I can put the rest of these numbers in really fast. That's going to be 0.5. That's going to be 2. And that's going to be 4.5. So unfortunately, we do have some decimals, but we'll approximate these on the graph. All right, so at negative 3, 4, and 4.5, it's going to be what? 1, 2, 3, 1, 2, 3, 4. 4.5 is right about there. Negative 2, 2. 1, 2, and right there. Negative 1, 0.5. Going to be like right there. And there's the 0, 0. And again, once you can graph these quickly too, once you know the first side. All right, so I'm just kind of quickly graphing these. All right, so those are my points. Let's go ahead and put in our sketch graph. And as you can see, when a is less than 1, or as a decreases, my graph is going to get wider and wider and wider. Okay? As it increases, it's going to get more narrow. Okay? Now, last thing. What happens when a is negative? Pause the video and see if you can think, try to guess. What do you think is going to happen to my parabola? All right. Well, let's find out, shall we? Okay, we're gonna do the same thing. We're gonna make we know our vertex is gonna be at 0, x equals 0. So it's gonna be, whoop, I need to do this in purple. Okay, so -3, -2, -1, 1, 2, 3. All right, there's my x. I'm just choosing those x values. Okay, at x equals -3. Okay, remember something very important. This says -x squared, correct? But really, you could say that's -1x squared, correct? Okay, so let's go ahead and substitute in -3. So -3 squared is 9. 9 times -1 is -9. Okay, at x equals -2. -2 squared is 4. 4 times -1 is -4. So I'm getting negative values, aren't I? At x equals -1. -1 squared is 1. 1 times -1 is -1. And that's just going to be 0, right? Because 0 squared, anything times 0 is 0. And now I can just fill in my chart here really quick. All right, so there I have my little table. So now let's go ahead and graph this. Okay, so I have x equals -3. X equals -3, 1, 2, 3. F of x equals -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now we're coming down here. At x equals -2. 1, 2. F of x equals -4. 1, 2, 3, 4. And at x equals -1, f of x equals -1. At x equals 0, f of x equals 0. Well, they all have a common point there, don't they? Okay, and at x equals 1, f of x equals -1. At x equals 2, f of x equals -4. And at x equals 3, f of x equals -9. All right, so here's what happens to my parabola. Look at that. Okay, so if you want to kind of label these, this is x squared, all right? This is 2x squared. This is 1/2 x squared. And this guy here is negative x squared. F of x equals -x squared, right? So now you can see what's happening with my parabolas. All right? So what I want to do is I want to make a table, select my x values, solve for my corresponding f of x values, and then just go ahead and plot my points. And you can see what happens when a changes from different positive values and also a negative a. All right? So hopefully this video was helpful to you. Make sure you subscribe to my channel so that you can get notified of any future channels, any future videos, I should say. All right? Until next time, may God richly bless you.